Hi, I'm Matthew Gore with lightandmatter.org, and today I'm going to talk about flash shutter synchronization. To understand how to use flash correctly and creatively in your photography, you need to begin by understanding how flash works with the shutter of your camera, and to do that, you need to understand how your camera's shutter works. Most digital SLRs today use mechanical focal plane shutters, and that's what I'm going to give you an example of here, but it's not the only type of shutter there is. But let me begin with mechanical shutters. Suppose you're taking a photo using a relatively slow shutter speed, like a 30th of a second or 60th of a second. Your camera's shutter module has two blades, usually called curtains. When you click the button to take a picture, the first curtain of the shutter slides down and starts revealing the image to the sensor, and it stays open for the duration of the exposure, and then the second curtain slides down to close the shutter opening, and then they both return to their original position to be prepared for the next exposure. Typically, when you're taking a flash photo, as soon as the first curtain reaches the bottom of the frame and the entire image is exposed to the sensor, the flash fires. That's known as first curtain sync. The duration of the flash is generally so short that it can be synchronized with either the beginning of the exposure, or with some flashes it can be synchronized with the end of the exposure. If the flash fires right before the second curtain starts coming down, but while the entire image is still visible to the sensor, it's called rear curtain sync, or second curtain sync. Now, let's take a look at how things work if you're using a faster shutter speed. The process starts out pretty much the same. You press the shutter button, and the first curtain starts revealing the image to the sensor. Let's say that you're using a 500th of a second shutter speed. After a 500th of a second, since the first curtain can only travel at a finite speed, it may have only traveled across the frame about halfway. But since the top of the frame has already received a 500th of a second exposure, the second curtain starts sliding down across the frame to cover it up. So at this point, both curtains are moving across the frame, with a slot between them that's allowing light to pass through. The faster the shutter speed, the narrower that slot will be. During the process, notice that there is no time at which the entire sensor is exposed to the light. For every camera, there's a specific shutter speed, a cutoff point, where this hasn't started happening yet, and the sensor is exposed to the entire image at once for at least a fraction of a second. The fastest shutter speed where that occurs is the camera's maximum flash sync speed. And this is why. Take a look at what would happen if you used a flash with a fast shutter speed like this. Since the sensor is never exposed to the entire image at once, when the first curtain clears the bottom of the frame and the flash fires, like this, the top of the image is already covered by the rear curtain. Its exposure has already been recorded, and it won't be lit by the flash at all. As a result, you end up with an image that looks something like this, with a dark bar covering part of the frame, although in this case, this wasn't flash photo, this is just a simulation. So before about 10 years ago, if you wanted to use a fast shutter speed, you simply couldn't use flash, with a couple of exceptions. But now, with modern advances in electronics, there's another option, namely HighSpeed Sync. With HighSpeed Sync, there isn't just one flash during the exposure. Instead, the flash produces continuous micropulses of light, so the flash head effectively becomes a continuous light source for the entire duration of the exposure. This means that as the slot between the two shutter curtains travels across the frame, each area is being lit by those micropulses of light and getting the same exposure. Unfortunately, this also means that the micropulses are much less powerful than a single flash burst would be, so HighSpeed Sync is primarily useful for fill light rather than as a main light source. Some older SLRs, like the Nikon D70, and most point-and-shoot cameras use electronic shutters instead. Basically, this means that instead of using something mechanical with moving parts as a shutter, the receptors in the sensor that record the picture are simply switched on for the length of the exposure, and then switched off again. This means that the entire frame is collecting light at the same time, so it's possible to sync the flash to virtually any shutter speed. This means that it's actually easier to take full-power flash photos in daylight with a point-and-shoot camera than it is with most SLRs.